Hello, guys. Good morning. A very warm welcome to all of you. My name is Neha, and I'm part of the developer relations team here at R3. I also have Ashutosh with me. So, so a very warm welcome again to all of you, and let's begin our the very first virtual Corda bootcamp for Singapore, especially for you guys. So, a quick introduction from my end. We both of us have been with R3 for almost a year now, and it's a you can say it's a super exciting job for me and Ashutosh. We focus primarily on developers using Corda, and we help them onboard onto Corda. We make and we try to make their life more easy. We help them from a technical point of view to solve their technical queries. We also do code reviews. We help them build their application by guiding them through technical demos. We also build certain sample applications. Apart from that, we also organize different meetups, conferences, interviews. We get feedback from the developers. We write blogs, articles on technical topics. And at the end, we also hang out on Slack channels, in office hours, and on Stack Overflow as well. So today, now for the next 2.5 hours, let's dive into Corda and let's enjoy this journey together. Also, feel free to post your questions, whatever you have in the chat channel. Ashutosh would be there to help you. Today again, what we're going to do is we're going to use, if you see in the bootcamp slides, if you see, we are going to use the ide.corda.net, which is an online IDE, and we're going to develop the Corda app today using this IDE. So make sure you go and visit ide.corda.net. Okay, let's move on. So, as far as the agenda for today is concerned, what we'll do is I'll start by giving a brief overview of how Corda works, and then we'll also see how it differs from other blockchain platforms. And we'll also look at certain key concepts. And once we're done with that, what we'll do is we'll try this very basic, simple CorDapp, a simple Corda application, and then we'll set up a local network and we'll deploy this Corda on this Corda app on a local network, and and that's what is planned for today's agenda. So all of us will write the Corda app together, and we'll deploy this Corda app onto a locally deployed Corda network in the next 2.5 hours. Okay. So moving on. So basically, let's start off with directly, let's jump into Corda. Okay. So basically, what do you think? Like, what is Corda? So basically to understand Corda, we should also understand how traditional blockchain work, or how traditional blockchain are not fit for business. So, so Corda is basically a permissioned private blockchain network per se, you can say. But again, as I mentioned, to understand Corda, we first need to understand how the traditional, typical blockchain networks are structured. So, I would say, in a traditional, typical blockchain network like Bitcoin or even Ethereum, the very first thing which comes to our mind is anybody or any anonymous party can join the network. Again, in such kind of public blockchain, the data is broadcasted to all the nodes within the network. Again, the data is broadcasted on unencrypted channels. Everyone has a copy of the entire data. So since the data is broadcasted to all the nodes within the network, each and every node within the each and every node within the channel, or each and every node, sorry, within the network, it has the copy of the entire data. And again, because of this, there's no privacy. And again, the proof of work consensus is heavy. So heavy proof of work consensus algorithms are required at a network level. Why? Because the data is shared between all the nodes. Everybody has a copy, and therefore the consensus is required at a network level. And that's why a heavy proof of work consensus is required at a network level, since data is broadcasted to all the nodes at a network level. And because of this, what we can say is that finality is not instant. And that's why we say that it is probabilistic finality. That is, you cannot guarantee the finality to be instantaneous once a transaction is committed. And this is the problem with public blockchains. So you might have to wait for certain, let's say, some X confirmations to truly trust the transaction. And 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 clearly this does not meet the needs of real enterprise business, right? It also gets pretty difficult to integrate with, let's say, you have your legacy applications. So it becomes quite difficult to integrate with these kind of public blockchains with your legacy application. So moving on, since we've looked at the traditional blockchain platforms from a very high level. We've looked at the traditional public blockchain platforms from a very high level. Now, let's dive a bit into Corda a little more. So as you can see in the diagram, this talks about that Corda is a permission node which has a well-known legal identity. So, so if you look into the diagram, what this is basically depicting is, this is a typical Corda network where there are three parties. There's Titan, there's Bay, and there's Acme. These are the three parties who are part of the Corda network. And then we have a Notary as well. We talk about Notary in some time, but as of now, just assume that we have a typical Corda network setup with three parties, which are part of the Corda network. So, so in real world enterprise business, you need to know who the other counterparty is, right? So basically, to meet the needs, you can say, of business or real world uh, enterprise business, Corda networks in itself, they are structured or they are architectured very differently. So before even joining the network, each owner, it undergoes a KYC process to obtain an identity certificate. So if you see in the diagram, before even these nodes, that is before even Titan, B, and Acme, they want to or they wish to join a particular Corda network, what they will do is they will request for a KYC, and each node owner will undergo a KYC process, and then they will obtain an identity certificate. So basically, each and every party who joins a particular Corda network undergoes a KYC, and this is how we say that each and every node which are a part of the Corda network, they have a well-known legal identity. After joining the network, they publish these certificates. So these nodes, they publish the certificates indicating, let's say, the legal name, the IP address, and the public key to a particular service, which is called as the network map service. And this is how the parties become visible to each other. And this is how the parties will now be able to transact with each other. Moving on. Again, communication between Corda nodes is on a point-to-point basis, and facts are shared only on a need-to-know basis. So if you remember, we spoke about the public blockchain where data is broadcasted to all the nodes within the network, and everybody has a copy of the entire data. But this is not true with Corda. With Corda, the data is shared only when it is required, and it is shared only on a point-to-point basis, and it is not broadcasted to the entire network. So only the parties who are involved in a particular transaction, they will get the copy of the data. So let's say that Titan and Bay, they want to perform a transaction with each other. Let's say that Titan has a vehicle, and let's say that Titan wants to transfer this vehicle to Bay Transcom. So in this particular situation, when the transaction is successful or when the transaction is executed, only Titan and Bay will have a copy of this vehicle data. Acme, though being on the same network, it will not even know that such a transaction took place between Titan and Bay. So again, the data is shared within the peers on TLS encrypted channels. So the communication is always safe with Corda, and it is shared on a TLS encrypted channel. Again, if I'd really have to talk about finality in this case, then you could say that finality in such a situation will be instantaneous. And now you won't actually have to wait for certain X confirmation to achieve finality. Now, why? Because in public blockchains, since the data was distributed or broadcast to all the network or all the nodes within the network, finality as such or the consensus was required at a network level. But here, if you see that the data is distributed only on a need-to-know basis, and only the parties involved within the transaction get the copy of the data. And that's why you can say that the finality or the consensus is not required at a network level, but the finality is sufficient at a node level. So that's why you can say that the finality is instantaneous, and that's why the finality is actually achieved at the node level and not at a network level. So moving on. Again, if I really have to touch base on Notary from a very high level as of now. So we have pluggable consensus using Notary pools. So as I mentioned, there is a particular node called as Notary. We look into the details of what the Notary is, but as of now, just keep this in mind that heavy proof of work consensus algorithm is not required, as the consensus will be at the node level and not at the network level. So, so basically, this pluggable consensus is achieved using Notary, and Notary takes care of, you can say Notary takes care of preventing double spend. So what do you mean exactly by double spend, or how double spend is prevented using Notary? So let's take a look at that in detail in the next slide. But as of now, just keep this in mind that the consensus is always at not at a network level, but at the node level. The finality is again at the node level. And because of this, the finality is instantaneous. And we use Notary to prevent double spend. So you can say that this will increase the speed, the performance, and you would also be easily able to scale your Corda app. Again, just to mention, Corda is open source, and we get a lot of community contributions. And usually the upcoming roadmap of Corda is totally decided by the community, by its partners, by you, the developers who use Corda. So just go ahead and download the Git repo and start contributing as well. So moving on. So till now we saw how Corda is different from traditional blockchain applications. And we saw a lot of things like how how Corda network is architectured completely different. And we saw that how data is not broadcasted to all the nodes. We saw how data is broadcasted on, or rather, how data is sent on only encrypted channels. We also saw how only permission private, or we also saw how only legally identifiable counterparties can join the Corda network. We also saw how the data is not. Uh, we also saw how each and every node doesn't have a copy of the data, and how data is, you can say, distributed only on a need to know basis, only on a point to point basis. And we also saw that um, how finality is instantaneous with Corda, and how it is not instantaneous, or how you have to wait for certain X confirmations with public blockchains. So this is how Corda has its own unique architecture, which you can see, which makes it different from the traditional blockchain architecture. So moving on.
Yes, Neha. Sorry to interrupt, but we have a question here, which I think you should probably just address for the sake of the
Yeah.
entire everyone who have joined this. The question says, can you help me understand how Corda is different from current non-blockchain world where a central body act as a trust entity? Is notary pool in Corda just acting as the same trust entity? So probably you want to explain the notary pool a little in details.
Yeah. So basically, everyone would think that Notary, again, it's a central entity, but Notary is, as such, it is not a central entity. And okay, so if you go back to the Notary slide. Yeah. So essentially, what happens is, so notary can be of different types. Okay. So the very first thing is, notary is, at the end of the day, understand this, that notary at the end of the day, it is nothing but a normal node as other nodes. So it is just like Titan, Bay, and Acme. It just has certain additional capabilities of preventing double spend. Now, you would say that in public blockchains, since the data is distributed to all the nodes within the network, you, as such, you do not require anything as such as notary, because everyone has the copy of the data. And because of this, everyone contributes to the consensus. And because of this, you can say that everyone within a particular network, since they contribute to the consensus, they prevent double spend. But in a situation where in Corda, where, as I mentioned, it is completely architectured differently, where the data is not shared to the entire network, and where it is shared on a need to know basis, we would want to prevent double spend. Now, when I say double spend, what I mean is, let's say that Titan has a car registered on its name. And let's say that Titan wants to transfer this particular car from Titan to Bay. Now, what we want to make sure is, as I mentioned, that data is only distributed on a need to know basis. And because of this, the transaction details between Titan and Bay would only be visible to Titan and Bay. Now, this transaction details won't be visible to Titan and Acme. And because of this, you might have a question of, then how would we prevent Titan from selling the same car which he sold to Bay to Acme as well? So this is basically double spend. So how do we prevent Titan from selling the same car to two parties at the same time? So for this particular situation, we would require something which would take care of preventing double spends. Now, if you look at Notary, Notary is the guy which will help Titan to prevent double spend, or which will help the nodes within a particular network to prevent double spend. Now, how this is achieved is, you would say that Notary is a central, you would think that Notary is a central authority, and it will see all the transaction details, and each and every transaction will have to go through Notary for preventing double spend. But then, as we'll move on, we'll see the exact details of why Notary as such, it doesn't look at the entire transaction, but it just receives a hash of a particular transaction which is already executed. So whenever Titan will transfer a particular car from Titan to Bay, this particular transaction hash will be listed down by Notary in a particular table. Now, again, if Titan tries to sell the same car to Acme, Notary will just look into the table and check if the transaction hash exists. If it exists, it knows that a double spend is being prevented. And that's why, and that is how it will simply reject the transaction. And this is how it prevents double spend. Now hold on to how the table is maintained and how what transaction details are saved into the table. Now moving on from the main question. Ashutosh, if you go back. So moving on to the main question, which was asked, that is Notary a central authority? Now, now keep this in mind that whenever we have a particular Corda network, what happens is usually there are different parties. They basically they form a consortium. Once they form a consortium, there are certain rules which define this a particular network. So let's say that there's an insurance network, and let's say that there are 5 parties, and let's say that these 5 parties they form a consortium. And what happens is when they form a consortium, at that point of time, they decide certain rules of the network. So this Notary which you see is basically defined by these five nodes which are part of the consortium. Now, each and every node, which let's say these five nodes which are part of this consortium, this each and every node can have its own Notary being represented as a part of Notary pool. So effectively, at the end of the day, you can say that this Notary pool, essentially, it can be just one Notary, which takes care of all the nodes to prevent double spend, or we can also have 5 notaries, uh, 5 notaries from each of the counterparties, and these 5 notaries they work together to prevent double spend. So in a way, if you see that the more the more notaries you add to this Notary pool, the more decentralized it becomes. So this is how the Notary pool as such, it is not a central entity, but rather you can say it's a decentralized approach of handling double spend. Yeah. Okay. So let's move on. Yes. So this is a typical Corda network. This was the consortium which I was talking about. So before even joining the Corda network, or before even deploying an application, what happens is parties they come together, they decide on the use case, they form a consortium, and and then they form the rules around the consortium, and then they form the rules around setting up a particular Corda network. Now this picture in the slide, what this represents is, this represents a typical Corda network. Now, from my point of view, there are 3 typical networks which you have to keep in mind. The first is the Corda network. We'll talk about that in a bit. So the Corda network is basically a global network. The second type of network is a local Corda network, which you can set up on your local machine. When we build a Corda app, excuse me. So when we build our Corda app later in this section, we will see how to deploy a local network. So Corda provides you with a tool to set up a local network. We'll look into that. So this is the second type of network. The third type of network is you can set up a private network for node interaction. We'll also talk a bit about that later. So the very first network which I said was, it is the Corda network. So the Corda network is typically, it's a publicly available a network, which is a publicly available internet of Corda nodes, and which is operated by the network participant. So this network, it went live in December 2018, and it is currently governed by an independent not-for-profit foundation. So if you look into the diagram, basically what it represents is the red circle, the big circle, it represents the Corda network. We have an identity manager or the doorman. This is the guy which is responsible to perform the KYC checks. And this is the guy who actually allows the party to enter the Corda network or to become a part of the Corda network. We also have the yellow dot which represents the notary. Also, we have Corda and Corda Enterprise, which have been deployed onto this particular network. So this shows that Corda and Corda Enterprise, how they can easily interoperate with each other. Again, so this is basically the Corda network. This is again, there's a process by which you'll be able to join the Corda network, the production Corda network. Also, there is a test network which typically represents, or typically you can say it resembles this production based Corda network. So you can very well go and join the test network as well. The second part of the network which I was talking about is a local network. So instead of joining the Corda network, what you can do is you can deploy your application on your local system and you can test it out. And then later you can decide to join the Corda network. Now, the main advantage of joining the Corda network is what it does is it offers complete interoperability. So the nodes can exchange, so different nodes who join this particular Corda network, they can exchange data, they can exchange assets via secure internet layer, via secure Corda's architecture. Now, eventually what will happen is, or what happens is as of now, that many networks, they've become a part of this Corda network. They've become a part of this global Corda network. So what we could have is basically, a hospital network. Let's say a hospital network talk to an insurance network, which let's say talks to a reinsurance network. And this is how assets or data can seamlessly be transferred between the nodes. And this is how different networks will be easily be able to talk to each other. And this is the advantage of joining the Corda network. But as of now, if you do not wish to join the Corda network, what you can do is you can set up the network locally, and then you can test out your application locally before joining the Corda network. Now, again, if you also don't wish to join the Corda network, what you can do is you can set up a private network within your own company. So let's say that your particular company will be responsible completely for managing your private Corda network. Okay, moving on. So a quick summary till now, what we saw was how Corda has a unique architecture and how it is different from traditional blockchain applications and traditional blockchain platforms, and how it allows private transaction by sending data only on a need-to-know basis, and how the parties are not anonymous, and how the transactions take place only between legally identifiable counterparties. And this is how we took a look at how Corda is a unique blockchain platform, right? So now what we'll do is we've seen from a very high level what Corda is. So now let's move on and let's look into the details of the Corda architecture. So I'm going to talk about three things now. I'm going to talk about states, contracts, and flows. So moving on. So basically, to build any particular Corda app, you require three things. You require to understand what a state is, what a contract is, and what a flow is. So as you can see in the diagram, the bigger circles, basically the bigger circles are represent the nodes. So Bob, Carl, Demi, Ed, Alice. These are the bigger nodes. These are the bigger circles which represent nodes. And the smaller circles which you see, the colored ones, they represent states. So before moving on to states, I would like to say that privacy is perhaps the most important requirement for a business blockchain, right? And yet traditional blockchain architectures, they share every fact with every participant on the ledger. And there is no privacy beyond pseudonymous public keys with public blockchains. But as I mentioned earlier, Corda, on the other hand, only shares information on a need-to-know basis. So, um, so what we can see is from the diagram that we can see that fact 1 is known only by Alice and Bob. So perhaps maybe it represents a trade between two of them. So similarly, fact 5 and 6 is only known to Bob. 5 and 6 is only known to Bob and Carl, and so on, basically. And these facts, so basically, other parties on the network are not even aware that these facts exist. So, in short, these particular facts are basically states. So, states represent what you can say, states represent on ledger facts stored in a node's vault. Um, so, so basically, let's say that let's say that um, so let's say that you want to so let's say that you want to make sure that what you see is what I see. Okay. So at the end of the day, why are we using Corda? Or let's say that why are we even using blockchain? Because what we want to make sure is we want to make sure that what you see is what I see, right? So in Corda, if you want to maintain this, that if you want to look into or you want to make sure that what you see is what I see, so all these details will go as a part of state in Corda. So in Corda, these shared facts are called as states. And these states, again, keep this in mind, that these states are distributed only on a need-to-know basis, and they are not broadcasted to the entire network. And these are the shared facts. Again, they are distributed only on a need-to-know basis. So moving on. So this is how now let's dive a bit deeper into states. So states represent on-ledger facts stored in a node's vault. So, so let's say that this is a typical Corda network, and let's say that, we have Titan, Bay, and Acme, which are parties to this Corda network. Now, let's say that Titan has a car and it wants to transfer this car to Bay. So, at any point of time, Titan and Bay, what Titan and Bay are interested in is they are interested to know the shared fact, or they're interested to know the information about this particular car, or rather they're interested to know who the owner is at any particular time of this particular car. So these kind of information, which both the parties want to make sure that what you see is what I see, will go as a part of the state. So that's why Titan and Bay, what we'll do is for Titan and Bay, we will create a state called as vehicle state. And this vehicle state will represent the shared fact on the ledger. So yeah, one more click. So a particular vehicle state, if you see how it can be represented on Corda. So till now, what we've seen is, just to recap, anything or everything which you want to make sure that what you see is what I see. Anything or everything which you want to make sure that all the parties involved in the transaction want to make sure that what you see is what I see, will go as a part of state. Any shared fact will go as a part of state. So basically, the very first thing will be you will have to identify what you want to make sure that what you see is what I see. So here, Titan and Bay, they've decided that they want to make sure that they want to see all the details, and they want to make sure that what you see is what I see for a particular vehicle. Or rather, they want to make sure that the owner or the make or the model or the year of manufacture or the cost or the owner at any particular time of the vehicle. So both of them, they want to make sure that both have a similar view of these details. So this kind of information, these kind of these kind of properties, which you want to make sure that what you see is what I see will go as a part of state. Now, how would you represent a particular state in Corda? To represent a particular state in Corda, so a particular state in Corda is simply a Java class. And what you'll do is, while creating the Java class, you will have to simply implement it with the contract state interface. This contract state interface tells Corda that this is a particular state, that this class represents a state. So this is how what you'll do is, the very first thing is you identify what state will be. Secondly, you create a class and implement it with the contract state interface. And the third thing is, you'll have to think over what are the properties which you want to make sure that what you see is what I see. So let's say that for vehicle, we want to make sure that who the owner is, or what the year of manufacture, or what the model is for a particular car at any point of time. We'll take all these we'll take all this information and we'll add them as properties within the state. So all the information which you want to make sure that what you see is what I see will go as a part of the state. Okay, as a state properties. Okay, moving on. So till now we spoke about state, which basically represents on ledger facts, right? So anything and everything which you want to make sure what you see is what I see will go as a part of the state, just to repeat it. Now let's again talk about the second component, which is the contract. So as I mentioned, to build any particular Corda app, three things are required: the state, contract, and the flow. So the second part is about the contract. So moving on. So before we even talk about contract, let's talk a bit about transaction. Okay. Yeah. Moving on. Yeah. So let's talk a bit about transaction before we move on to contract. Now we saw earlier that the ledger basically it is a set of shared facts or states. So what do you think? How is this ledger updated over time? So what happens is basically nodes update the ledger using transaction. Now a transaction is simply a proposal to modify the current ledger in some way. So a transaction typically, a typical transaction has 0 or more input states and has 0 or more output states. So you could say that if a transaction proposal is approved, the input states are marked as consumed or historic, and then they are no longer can be part of any inputs to any future transactions, while the output states are created on ledger and they become the current state of the ledger. So, so let's take an example over here. So if you click one more time. So what is happening is over here. Now, what are we trying to do over here is, as I mentioned, that let's say that there's a transaction which Titan wants to initiate from Titan to Bay. So what Titan wants to do is, Titan wants to basically, yeah, just hold on. So Titan just wants to, what Titan wants to do is, Titan wants to transfer the car ownership from Titan to Acme. Okay. So initially what happens is, at the very first time, Titan will issue a state, rather a vehicle state, onto its vault. When I say vault, I mean the database. So each and every node has a database associated with it. So Titan will issue a state, a particular state, which is a vehicle state, onto its vault. Now, if you look into the transaction, as I mentioned, a transaction can have 0 or more inputs and it can have 0 or more outputs. So what this transaction is doing is, this transaction is consuming or taking a reference of this input state. This input state has the owner, which is marked as Titan. So the owner of the car is Titan. And what we are doing is, we are generating a new state, which is called as the output state. And this output state has the owner marked as Acme. So this is a particular transaction which we are building. So we are consuming the input state, we are creating the output state. And if this particular transaction is successful, or if this particular transaction is valid, what we would say is that this particular input becomes historic and a new output state gets created with owner as admin. So this is how a transaction typically gets executed between different nodes, and this is how the ledger gets updated. So this is how the input will now be marked as historic, and this new output state will be saved on both the nodes database. And this is how the ledger evolves over time using transactions. Yeah, moving on. Now, typically, if you look into this diagram, this represents again, so transactions in Corda are represented using an UTXO model. Typically, there are different types of transaction. So this particular transaction view, here you can see typically there are three types of transaction which you can see in this particular diagram. If you look into the leftmost corner on the top side, you can see that there's a particular transaction which has 0 inputs and 1 output. So this particular kind of transaction, it represents an issuance transaction. In an issuance transaction, there are 0 inputs. That is, there are no inputs for this particular transaction, and there is 1 output or 0 or more outputs which are part of this transaction. So this basically means that I am issuing certain states onto the ledger. Okay, or rather, let's say that here, if you see into the diagram, I am issuing a cash state onto the ledger. I'm introducing the cash state onto the ledger for the very first time. So this is a typical example of an issuance transaction. The next type of transaction is the transfer transaction. If you look into the middle diagram, into the middle box, the middle box represents 2 inputs and 2 outputs. So a typical transfer transaction can have 1 or more inputs and 1 or more outputs. So here, typically what this represents is that we are transferring an asset from one party to other party. So this typically represents a car transfer, where what we are doing is we are taking an input. This input represents an on ledger asset, an on ledger car, and we are transferring or we are changing the ownership name from one party to other party. And this is how a new output is generated, and we are referring to an existing input, and this existing input is already saved on the ledger. So and the same thing goes with the cash as well, that we are referring to an on ledger saved cash, and for the card transfer, the cash, the other counterparty, the one party will give vehicle to the, so A will give vehicle to B and B will give the cash to A. So that's how the owner of the cash will also change from B to A. So this is a typical transfer transaction where we have 1 or more inputs and 1 or more outputs, where we consume existing on ledger facts and where we create new output states. So these new output states, they typically form the current ledger of Corda. And then we have a third type of transaction which you see, where there is 1 input and there is 0 output. So these kind of transactions, they represent an exit transaction, where let's say that we are no longer want to maintain the vehicle state onto our ledger. What we simply do is we simply create this exit transaction, where this particular input state will be marked as consumed and a new output state won't be generated. So simply this marks an exit of a particular asset. So this is how the transactions are basically linked to each other, and this is how the inputs and outputs are a part of transaction. This is how these are the different types of transactions. That is, we have issuance transaction, we have transfer transaction, and then we have exit transaction. And this is how assets or ledger evolves over time, and this is how the transactions are linked to each other. And this is how a particular output state of one transaction becomes an input state to the other transaction. And this is how whenever a transaction gets executed, the input state is marked as consumed and a new output state is created, which forms the current ledger of Corda. So yeah, moving on. So now let's talk about how Notary prevents double spend. Yeah. So as we saw in the earlier diagram, that transactions, they basically chain up, and transactions are always linked to each other. And we saw in the earlier diagram uh, that how outputs from a particular transaction form inputs to the next transaction, and how the transactions and how the input state when they're marked as consumed, and how output states are created whenever a transaction is executed. Okay. Now, if you look into this particular diagram, on the left hand side, we have a transaction one. It has 0 to n minus 1 inputs and it has 0 to n minus 1 outputs. Okay. So typically in a transaction, the output states, they're part of a particular list, and they are sequentially numbered from 0, 1 to up to n minus 1. Okay, so always keep this in mind that the output states are numbered from 0, 1 up till n minus 1. Now here in transaction 1, let's say that we have these two states, 0 and 1. Now, after that, what happens is this transaction 1 gets executed and a new transaction comes in, which is transaction 2. Now, for this transaction 2, we have two inputs to these particular transactions. We have the zeroth index output state from transaction 1 as one of the input. And we have certain other input from certain other transaction. Similarly, if you look at transaction 3, we are consuming the first index or the first output from transaction 1. And this is how the transactions are linked to each other. Okay. Now let's talk about how Notary prevents double spend. So let's say that now till now we saw what an output index is exactly, or rather how the outputs are indexed from 0, 1 up to n minus 1 in a particular transaction. And we saw how the transactions are linked to each other. Now let's see, now let's look at a practical example. So let's assume that Titan has a car. And so for the very first time, what Titan will do is, excuse me. So for the very first time, what Titan will do is, Titan will issue a particular car on its leisure. So this is a typical issuance transaction with 0 inputs and 1 output. And 1 output is of this vehicle state with owner equal to Titan. Now, whenever this particular issuance happens, what happens is the notary quickly records this particular transaction into a table into its own database. So if you look, you see that a transaction 1 and an output index 0. So a state was issued at output index 0 in transaction 1. So an entry gets added into this particular table saying that transaction 1 output index 0. Now, if you click one more time, now let's say that Titan, one more time. Now let's say that Titan wants to sell or transfer the ownership from Titan to B. So what essentially will happen is Titan will create one more transaction called as transaction 2. Now in this particular transaction, what we'll do is Titan will transfer the car from Titan to Bay, and in return, Bay will send some cash from Bay to Titan. That is, Bay will transfer certain cash from Bay to Titan. So as in transaction 1, we issued a car. Similarly, in TX transaction, Bay has issued cash onto its leisure. Now, simply what we'll do is Titan will create a new transaction called as the transfer transaction. In this particular transaction, the first input will be, we will consume the on leisure existing Titan car and we will create a new vehicle state with owner as Bay. And similarly, we'll do the same thing for the cash as well. So this is a typical transfer transaction where the vehicle state ownership changes from title to bay. So when we execute this particular transaction, an entry will be made into this particular table. So if you click one more time, so whenever I will execute this particular transaction TX2, if you look into the table, in the consuming transaction ID, so for transaction 1 output index 0, so this is a state, right? Transaction 1 output index 0, it represents a state where owner is title. So this state, whenever I execute transaction T2, this state will become historic. It will be marked as consumed, and an entry will be made in the consuming transaction ID saying that transaction 2 has already consumed this particular input state. So Notary, as such, if you look over here, it doesn't know what the state is or what the details of the state is. It only knows that there's a certain transaction. So here, as of now, we have written transaction 1, but ideally it represents a transaction hash. So basically, it just knows that there's a hash and this is the output index. So for transaction, for this particular transaction hash and for this particular output index, this input has already been consumed by transaction 2. So that's all it knows. Now let's say that Titan Technology is not an honest guy, and let's say that he tries to, double spend or tries to issue or tries to transfer the same car to Acme. So if you click one more time, what will happen is, let's say that Titan creates one more transaction, let's say transaction 3, and let's say that Titan tries to sell the same car to Acme. Now what happens is, Notary will, before executing this transaction, Notary will go and check into the table. And now it will know that transaction 1 output index 0 has already been consumed by transaction 2. So it goes and checks whether whether an entry exists for this particular output state. So if an entry exists for this particular state, it knows that that this particular output state, which is an input state to the new transaction, has already been consumed by some other transaction already. And that's why it will simply reject this particular transaction. If you click one more time. So, and that is why it will simply reject this particular transaction. And this is how it knows that this is double spend. So yeah, moving on. Now, finally coming to actual contracts. So we spoke about transaction. We spoke about what a transaction is, what an input state is, what an output state is. We also spoke about how Notary prevents double spend. Now, coming to contract is basically, you can say a contract is a function that takes the transaction proposal as an input, and it checks this transaction proposal against set of conditions. And if the set of conditions are all successful, then you can say that the transaction proposal is valid. And the transaction proposal is only valid if all the contract conditions are met. So what happens is, typically, if you look into this particular diagram, so Titan and Acme, again, they are doing a car transfer. So Titan is doing a car transfer from A to B or from Titan to Acme. So what Titan does is, Titan creates a transaction. In this particular transaction, it adds the input states and the output states. This particular transaction is run against set of rules or set of constraints, set of business constraints decided by both Titan and Acme. If this particular transaction is passes all the tests of the defined rules within the contract, then only this transaction gets executed. Then only we can say that the transaction is valid. Then only we can say that the input is marked as consumed and the new output state is created. And then only we say that the ledger can now be updated by this transaction change. So basically, this contracts basically, hence we say that they govern evolution of a particular state. Yeah, click one more time. So this was a situation where we saw that the transaction becomes valid only if the contract rules are all valid. Okay, now there could also be a situation where, let's say that whenever we run a transaction against a contract, if all so each and every rule must be satisfied for the transaction to become valid. If even if one of the rule which is defined within the contract, if it fails, the transaction is simply rejected and the transaction is marked as invalid, and the transaction is then simply rejected, and because of this the states are not evolved, the ledger is not updated, and there is no change within a particular state. Okay, so that's how a particular transaction is always governed against a set of rules which are defined within the contract. Moving on. So now we saw what a contract is essentially. Now if you really have to define a contract within Corda, what you have to do is you have to contract in Corda is a typical class which implements contract interface, and this particular interface has a verify method. So as I mentioned, you have what we do is we run this contract, or we run this contract against a particular transaction. A transaction is a proposal, right? So this proposal is run against set of rules defined in this verify method in the in this contract class. So what you do is you basically decide what are the rules would be for your particular contract, define them in this particular verify method, and then simply if you look into the verify method, each and every rule is valid, or each and every rule is successful, and that's why we say that this particular transaction is valid and this particular transaction can be executed and the cash can be transferred from Alice to Bob.
So
uh,
yeah, just a second. I think
yeah.
we have certain issues with the streaming. There's some technical glitches. I guess they're not able to see. I think the video live. I guess there's some problem.